Hey, what is going on? It is Monday, April 25th, and welcome to the new week. Yes, Monday, a good day to start off with some coding chops. So welcome to Coding with Chef, where the code happens and you happen along with it. Obviously, I still haven't found a good slogan, whatever. So, if you, by the way, before I begin, we're going to talk about this problem, peaking iterator. Can you do me a favor and like and subscribe to this video and comment below? Let me know how I'm doing and what I can improve upon. And yeah, just generally, I hope these videos help. It's kind of an overcast day today, so this is just going to help boost my spirits and also give me some good practice with this apparently classic problem. The problem is called peaking iterator. It's number 284, which means it was one of the early problems in Leetcode. And let's see, it says that Google was one of the companies that asked this question. I don't know how accurate this is. Supposedly Leetcode says that this is accurate, and 0 to 6 months, within the last 0 to 6 months, it's asked something like this question. So whatever, take it for what it is. It's an interesting question either way. So just a reminder, all code is referenced in the discussion thread that I have. Specifically, I write that thorough discussion thread for every piece of code that I work on here on Leetcode, so you can really go through it and digest what's going on in my thinking process. I'll link that below in the video. So the question is, design an iterator that supports the peak operation on an existing iterator in addition to the has next and next operations. Implement peaking iterator class. Peaking iterator initialize the objects with the given integer iterator. Next returns the next element in the array and moves the pointer to the next element. Has next returns true if there are still elements in the array. And peak returns the next element in the array without moving the pointer. Each language may have different implementation of the constructor and iterator, but they all support the next and has next functions. Okay, so here's an example, and this iterator is very common in Java and Kotlin. It's used as kind of the generic way to iterate through a collection, one of the any of the list type collections or linked list, or any of these kinds of any classes that inherit from collections, right? So the peaking iterator example 1 has an input of peaking iterator, next, peak, next, has next, and you see 1, 2, 3, and then the output. So that means the peaking iterator has populated, or it contains 1, 2, 3, because it's passed an iterator object, and the output is null, 1, 2, 2, 3, false. So how does that work? So next, in the initial call, will return 1. Okay, then that'll move this internal pointer to 2. So the peak doesn't move the internal pointer, it just looks at 2 and returns 2. Next will actually return the value of the current pointer and move the internal pointer, so it returns 2 and then moves the pointer to 3, and then 3 again, next is called and returns 3, and therefore that has next called. We're at the end because the final next moved the pointer to the end of the iterator, and the final call was false. Okay, because there's no more elements after you move the pointer to the end. So that's generally how this works. Okay, now what you might be thinking is, let's talk about our first solution. And our first solution could be something like, you might just be like, okay, well, why don't I just have an int nums equals int length number of elements in iterator, and I can just copy all the elements to the iterator in the constructor, and then just the peak operation will be just looking at the head of the array. Okay, so that means that we'll just be like, return nums of head. And okay, we can do that, and that's like a little too obvious, right? Because that's a pretty easy solution. If it's a Google question, right, it's doubtful that such an easy solution in the most optimal sense. The most optimal solution is definitely not easy, but it's a medium problem to boot. So what can we do? Like, you would, as fast as we can get, like we can intuitively know that the fastest we can do is n, a number of elements in the iterator O of n. But what else can we do? Well, we can actually optimize space here. And how do we optimize space? Well, it's a matter of, remember, we're iterating through the elements one at a time, right? So what we can do, I'm going to put a few variables down here. Okay, then what if we, instead of using our next to do iterator.next naively rather, like we don't want to just right away get the next value, because this would defeat the purpose, right? There's no point. We want to essentially prevent going through every element unnecessarily, right? And we don't want to save this space in the beginning. So what if, instead of saving all the elements again and iterating through them, we maybe only save the next element? Okay, you'll see what I mean in a moment. But so I'm going to put a few variables here. Last found false. Okay, last popped equals false. You'll see what I mean by these. And next. So I'm going to save the next value, and I'm going to move the iterator internally whenever next is called. Whenever the peak is called, I'm just going to return the next value without moving the iterator internally. And now, that seems also a little too simple, and it is. It's not that simple, because you have to count for when the iterator is truly at the end of the iterator data structure has next. So really, the work in this algorithm and data structure really involves the use and the correct return value for has next. So let's try if iterator dot has next. Okay, so what I'm going to do in this, I'm going to initialize the initial values of the data structure. Okay, so I'm iterating through and checking, has this iterator initially, remember there's three conditions state this iterator can be in, right? If we consider this a little bit of like a state machine. We can either be not at the last element and be somewhere in the middle or top of the iteration. We can be at the last element, but we may not have removed the last element, or the iterator right from the get-go can be empty, and we don't have anything in it. So all these three states can be accounted for first in the constructor, like this. Or else equals true. Last top equals true. So basically, if the iterator has a next value, right, we save that next value, and then we check again, does the iterator have a next value? And we check right afterwards, right after we've iterated. And if we do find the next value, the fact that it has a next value, we save that as the last element last found. So that's this. In this case, this means the last element was found, and we're at the end, but have not removed last element. This is important, okay? In this case, since this constructor, doesn't actually, the constructor, the other thing that the constructor can be passed is an iterator that is empty already at the end. In that case, we've already found the last element and it's already been removed. So we'll set this last found to true, and this last popped, or last removed, I call it popped, whatever. Last popped is also true. And that means this iterator, by default, will return nothing. So peak function is actually pretty straightforward. We just return the next value. And the next value could have been obtained from here, iterator.next, from the initial constructor call, and it's the cached value. We're not actually, remember I said we're not actually moving the iterator along in this way here. So therefore, like if we have elements 1, 2, 3, we return, the pointer is like here, right, at 2, but we're returning this value 1 because we don't want to move the pointer on a peek operation. We want to keep the pointer the same. So the pointer is here if the star indicates where the pointer is, and the peak pointer, or I guess you can, if you call that plus, is here, whatever. Okay, it's still at the beginning. So just remember that, and that plus peak is cached at next. So let's try the next operation. So the next operation is, this is where again, another place where complexity is. So we need to count for several cases. If last found, last popped equals true, return next. So if we found that last element on a previous iteration, we haven't necessarily removed that last element again. In our example, 1, 2, 3, we could be here and we found this last element, right? But we haven't removed it. If we removed the last element, we'd move the star over here. And we need an indicator to show that we've removed this last element. That's why I have this last popped here, okay? It's important to remember. You'll see. So let's say we haven't removed the last, we're not at the last element and we haven't removed it. Int is next. Iterator as next. So now we're implementing similar logic to what we did in the constructor, and we could probably, dry this code up a little bit and yeah, do some stuff with it to make it more reused and with what's in the constructor, but let's just keep it this way for now. Okay, so now what is this previous? This previous is important because when we do a call to next, we are not actually returning the next. 1, 2, 3. When we do a call to the peaking iterator's next value, we look at what the previous value was cached. Let's say the previous value that was cached was 1 and the actual iterator is 2. So what we need to do, we need to shift plus, and we need to move the internal iterator's pointer, right? So this previous is saved by this 2 here. We're caching this. This is the internal iterator's next pointer. We move that, and then we do our check to see if the last element was found, kind of like what we did in a constructor. And if the last element was found, just set that bit to true, okay? And then we return the previous value, returning this, okay? Because we're looking at the peak. This is the peaking iterator's next pointer. This is the internal iterator's next pointer, okay? And at some point we'll have this situation, and that's what the first condition is referring to. If we found the last one and we've not popped the last one, and if we found the last one and if we popped the last one, then we should be here at this state. And if this is the case, then we must account for the true has next. I can call this as true has next, as whether the last element was popped, whether the peaking iterator's pointer is truly at the end. Now let's run this. Accepted and accepted. Okay. So you can't really trust, again, Leetcode success metrics, but we can say that this is an O of n operation in time, and if you don't count the internal iterator as space, a lot of people don't consider the parameters data structure as additional space, then this would be an O of 1 operation. If we save in additional array. If we saved an additional array, then this would be an O of n space operation and be much less efficient. Okay, so that's it for today's coding challenge. Thank you for watching. I appreciate your time, and yeah, leave a comment and we'll talk again later. And have a good day, do your work, and all that stuff. See you around.